So we have looked at a couple of demonstrations, a couple of examples of the Pythagorean Theorem about why it's true. The formula for the Pythagorean Theorem says a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. The squared means we drew squares off the legs, and the area of the two squares off the legs added together equal the area of the square off the hypotenuse. So leg squared plus leg squared equals hypotenuse squared. Another way to say that is the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. That's pretty wordy. We generally leave it as a squared plus b squared equals c squared. All right, so what we're going to use the Pythagorean theorem to do is to find unknown sides of right triangles. So this first problem, notice that they want us to find c. Well, c here is the hypotenuse. It's across from the right angle. They give us the lengths of the two legs, and we have to find c. So what we're going to do in general is we're going to write a squared plus b squared equals c squared. Yes, you're going to memorize that pretty quickly, but write it so that you plug the correct thing into the correct place. So a is the square root of 10, so the square root of 10 squared, plus b is the square root of 40, so the square root of 40 squared, equals c squared. Now, you learned how to put this in your calculator. Also, you don't even really need a calculator here. Remember that a square and a square root are inverse operations, so they cancel each other out, and you're left with the radicand. So the square root of 10 squared is 10. The square root of 40 squared is 40. So 40 equals c squared. So 40 plus 10 is 50. 50 equals c squared. That means if we were to draw the squares, this square over here that we draw off here would have area 10. This square would have area 40. 10 plus 40 is 50, so the area off the hypotenuse would have to be 50. Well, I don't want the area of the square. I want the side length, right? So I have to take the square root. The inverse operation of squaring is taking the square root, so I'm going to take the square root of both sides, and I get c is the square root of 50. There's a couple of things we could do here. It depends on what the question asks. If it says to find it exactly, that means we don't want to plug this into the calculator and get a decimal. If it says to round it, we do want to plug it into the calculator and get a decimal. But the one thing we want to look at, if it says to find it exactly or to not get a decimal, is can I simplify this? And I can. So the square root of 50, that's 25 times 2, equals c, so that would be 5 root 2. So the length of that hypotenuse is 5 root 2. Okay, look at the next one. Notice it says to find b. So I know the hypotenuse. The hypotenuse is the square root of 26. That leg is square root of 8. I want to find b. So I'm going to write my Pythagorean theorem. A squared plus b squared equals c squared. I'm going to say a is the square root of 8 squared, plus I don't know b squared, and c squared is the square root of 26 squared. You can plug this into your calculator, or you can know that if you square a square root, you get the radicand. So the square root of 8 squared is 8, plus b squared equals the square root of 26 squared is 26. Now this is going to be like a one-step equation. We're going to subtract 8 from both sides, and we get b squared is, what is that? 26 minus 8 is 18. So I'm solving for b. So I don't want b squared. B squared is the area of the square off of b. I want the side length. So my inverse operation is taking the square root, and I get b equals the square root of 18. Well, that simplifies. 9 times 2, and b is 3 root 2. Okay, Notice we're only using the positive square root. Remember we've said when we take a squared equation, there's two answers, the positive and the negative square root. Well, the side length of a triangle can't be negative. We could not have negative 3 root 2, so we only use the positive square root. Okay, this one says a right triangle has sides of length 2.4 centimeters and 6.5 centimeters. What is the length of the hypotenuse? It's always a good idea if they don't have a diagram drawn for you to draw one yourself. So I have a right triangle. One leg is 2.4 centimeters and the other leg is 6.5 centimeters. And they want me to find the hypotenuse, and I'm going to label the hypotenuse C. So we're going to do this like any other time. We're going to write the Pythagorean Theorem. We're going to plug in our leg length. So we're going to have 2.4 squared plus 6.5 squared equals C squared. We're going to use our calculator to help us. 2.4 squared is 5.76. Plus 6.5 squared is 42.25. I'm going to add those up. And I get 48.01. So that is C squared. I don't need C squared, I need C. Can you tell me, can you look at this and estimate what C is going to be? Okay. If C squared is 48, then C's got to be close to what? 48 is close to what perfect square? It's close to 49, so the square root is close to 7, right? So that's what we would expect. Since this is a decimal, let's take the square root of both sides, and this time use your square root key on your calculator. Take the square root 48.01 and you get a big ugly decimal, right? So we want to approximate that. We're going to round it. Let's round it to the nearest tenth. So I get 6.92, so that would be 6.9 centimeters, right? So that's close to 7. That's sort of what we expected. So if they give you a decimal, if you have to do something that's not nice and pretty, you can round it to the nearest tenth. Okay, let's look at this one. It says a right triangle has a side of length 1/4 and a hypotenuse of length 1/3. What is the length of the other side? So, oh no, the dreaded fractions. Well, let's draw our right triangle. That's not a very pretty right triangle, is it? One of the side lengths is 1/4 and the hypotenuse is 1/3. We do not want to change these to decimals. Why? Well, this would be okay, right? That's a terminating decimal, and that would not be a problem. This is a repeating decimal. We would have to cut it off. We're rounding. It would be imprecise. So we want to use these as fractions. If it's a fraction problem, keep it as fractions, okay? So let's write our Pythagorean theorem. If I have a pen, that might be helpful. All right, so a squared plus b squared equals C squared. Now, we don't know if we don't know A or B, and it really doesn't matter, okay? You're just going to pick one of the letters, A or B, and label it. The legs don't matter. The only one that matters is the hypotenuse. C has got to be the hypotenuse. The legs can interchange. It won't make any difference, okay? So A squared plus B squared is 1/4 equals C squared, which is 1/3 squared. Okay, so A squared plus 1/4 squared equals 1/3 squared. So you can use your calculator to help you square these fractions. These fractions can probably be squared without a calculator. 1/4 times 1/4 is 1/16. 1/3 times 1/3 is 1/9. Okay, so now I have this equation. I'm going to subtract 1/16 from both sides. and I get a squared equals, and this is where your calculator is going to be helpful. You can do this by hand and find your common denominator and everything, but I would use that fraction key. Remember, it's your ABC button. So you're going to do 1 ABC 9 minus 1 ABC 16th, and you should get 7 over 144, okay? Now, this is looking kind of ugly, but that's okay. It's a fraction problem. We expect ugly. So we're going to take the square root of both sides, and we get a equals the square root of 7 over 144. Now, the square root of a fraction is not ideal. If we can fix it at all, we need to. So we can split this up. We can take the square root of the numerator over the square root of the denominator. Now, the square root of 7, I can't do anything with that, so I leave it. The square root of 144 is 12. So A, the side I don't know, is the square root of 7 over 12. Okay? So you have a practice page with some practice problems and the Pythagorean theorem. Do those and see if you know what you're doing.